AI is becoming incredibly good at helping with our tasks, writing boilerplate, sorting data, summarizing notes. But automating those tasks doesn't mean we're outsourcing our purpose. It's about freeing us up to solve actual problems. The challenge for AI in 2026 is building the infrastructure that makes that handoff reliable so that we can focus on the bigger picture. Joining me to help cut through the noise is Steve Watt, VP of the Office of the CTO here at Red Hat. Welcome to Technically Speaking, where we explore how open source is shaping the future of technology. I'm your host, Chris Wright. So, Steve, traditionally, emerging technology worlds, research worlds, think about that 3-5-year horizon. We've always pulled it back to be more like 18 months plus because of the speed of innovation in open source.
Yeah.
Now we're in a completely different world with AI. How do you think about emerging technologies and what's coming in a space where there's new things every day?
Yeah, it's a great observation, and it's totally true. I often joke about the fact that with generative AI, it feels like we're on a treadmill, and every week someone's increasing the speed, right? So our group is a pathfinding group at Red Hat, so that we try to identify what's coming down the road and then align Red Hat to be ready for it when it arrives. And so I have teams of researchers and emerging technology software engineers or machine learning engineers, and we spend a lot of our time identifying where the right open source innovation is happening and which open source projects. That sometimes involves like what I'd call serial offenders, that people that we know lightning has struck multiple times with him having big ideas and then being big impactful engineers. And so we follow folks like that. We also work with a lot of key universities. So we have a couple of strategic university partnerships where we're engaged with specific researchers to get us that insight really early around projects that could be really impactful. So that's the basic playbook. And then once we've got something, we develop prototypes around it and work with our product engineering teams and our product management functions to calibrate those prototypes so that they're ready to be used in the way our customers want to use them.
Yeah, that's great. Sort of following the innovation and then mapping that to the enterprise world where real users need to meet this technology and put it into production.
Yeah, exactly. It's almost like working with a clay wheel. You know, you start with this lump of clay and then you kind of shape it into something that our customers are able to consume, you know.
So what are some of those areas of focus? I mean, broadly, you've got a lot of folks really interested in AI, thinking about from a Red Hat point of view, the areas that we're focused on, from inference and distributing that inference capability and model choice. But what are the key areas that are worth highlighting as far as key trends for this year?
Yeah, I think, the way we tend to think about, we sort of have a focus area for about 6 months at a time. And we often find that even in those 6 months, the world changed so much, we have to change the plan. But for right now, I would say that, we're quite focused on agent creation, operation, zero trust for agents. And so we've got a space there like reinforcement learning that we're looking at. But I would say one of our most exciting areas right now is around the inference platform itself. And there's a lot of really interesting work happening there. Concepts around, we've had mixtures of experts, but now we have a sort of concept of mixture of models. And so the ability to do composable intelligence with an effective sort of inference router. So I think that's pretty interesting. And then also multimodals arrived from a self-managed standpoint. So there's the vLLM-Omni project, which I find quite interesting. So I think those are two key areas in the inference layer that I'm quite excited about.
Let's dig into that routing layer a little bit. So,
sure.
There's it's turtles all the way down in terms
Sure.
of continuing to choose where and where to route requests. But from your point of view, at that top level, you got an inbound request. What's happening after that?
Yeah. So I think, if we look at the way it works today, on a self-managed setup, you tend to get the best performance from these frontier models, right? So you can go to Hugging Face from the ones that are available, your model registry. You can pull those down, and they will tend to give you the best performance. But it's sort of like pulling down the whole of Wikipedia, and they can be a little unwieldy to work with. You actually have to have the hardware that can run a model that size efficiently. And then typically you want to do something with it. because it's such a large general purpose model, it can do a lot of sort of general tasks, but if you need highly specific tasks, then you might need to post-train the thing. And then that also starts to become a little unwieldy. And so I think a different way to look at this problem, and which is a little more open source, right? Which the one of the tenets of open source is choice, where you're able to go and get the right thing that you need and then like change it to be exactly what you need. Like, how could we bring that concept to generative models? And so this is sort of the idea behind this project called the vLLM Semantic Router, which was actually created here at Red Hat. And it's now inside the vLLM project as a subcomponent. But what this allows you to do is pick a series of smaller purpose-built models. So if we continue with the Wikipedia example, right, you could have a model that's focused on physics and one on history and one on sports, and as the requests come in, you can do fixed routing to these, or you could do semantic analysis on the inference request, and basically, based on what's being asked, you could route it to the correct thing. And I think that's a really fundamental shift in the way that we construct the ability to reason. And I'm pretty excited about it.
Yeah, I can see the utility already. The specialization is one example. There's policy concerns around when and where to use large SaaS models versus small locally hosted models. There's cost differences. There's data concerns. Even that point of intercepting a request is the same sort of gateway point where you would build reinforcement learning loop. So there's a lot of importance that happens right at that request response boundary.
Yeah, absolutely. And I think like another thing that's like different from the whole value around, choice is cost, and control. So, the idea of like, okay, look, maybe my self-managed models perform so well, but there is this like frontier SaaS hosted model that performs better because they have a team of geniuses like making that thing better every single day or something. But like, how do you choose when, or what could you use to be able to decide when you can go to what you self-host and have self-managed and built versus when you go up to that more expensive SaaS-hosted model? And this component gives you that ability to do that. It's a place where you can inject policy. And so, whether that's routing policy based on certain criteria or even pluggable modules that, hey, if this thing has PII in it, either don't respond to the request, shut it down, or that's okay if it's going to my internal systems, but not if it's going to the cloud.
Yeah. Interesting to bring privacy into that and the policy, because it also draws in some questions around not just where you host the models, but even in some cases, how you host the models. And I know one of the areas you've been experimenting with is confidential computing applied to inferencing. So let's dig into that for a second.
Yeah, sure. That's a super fun space. So the problem is, you may pull down a frontier hosted model, which is great. There are capital moats that prevent most of us from producing our own, but you may want to post-train that thing to inject your own data into, and that may be proprietary information that you don't want other people to have access to. And so being able to protect the model weights is an important it's a concern to some folks that are doing this type of post-training, or maybe they have pre-trained their own smaller model, like a small language model. But now they want to allow people to use this model, but they want to be able to run it in an environment that's outside of their control. So the analogy I use is, I think we all know the ingredient mix to Coca-Cola is a trade secret. So the problem is sort of like trying to talk Coca-Cola into making Coca-Cola in someone else's factory. Obviously Coca-Cola would have concerns about their recipe being discovered, right? Sort of similar idea with these model weights. And so we have a prototype that leverages confidential computing, secure enclaves, integrity measurement that allows the model provider to control the environment even though it's running in a third-party environment where their model is, just that component of the inference server. And if anything happens to the model, there's any hardware or software changes, the integrity measurement will catch it and trigger an event which they can do what they want with, but usually it means they'll destroy the virtual machine that the inference server is running in, and their model weights will be protected.
Yeah, managing both integrity and privacy of the content inside the...
Yeah, absolutely. Yeah.
Which gives you choice and flexibility in where and how you deploy a model. It doesn't have to be always within your own data center, or conversely, proprietary weight models could be safely deployed into somebody else's infrastructure, not a SaaS hosted service anymore, but potentially in a data center. We've already seen some examples of that. So I think there's a lot of interesting opportunities with confidential compute.
Yeah, I think it's kind of a nascent space, and I think where the industry, and that includes sort of the open source communities, are still kind of getting familiar with the concept, and people that are innovating are becoming familiar with this is an option I have when I build my models. But I do see growth, especially around healthcare, with patient data injected or information that's being derived from patient data and things like that. I think that there's a lot of opportunity for it.
In the inference space, we talked a little bit about that routing tier, some policy and privacy that can be implemented, even confidential compute. You mentioned multimodal. Obviously, that's a big topic. We capture a lot in text, but not everything. And even what seems like a text could have an image in it with text embedded in the image. So getting that whole context is really important. What's happening in the Omni project that's worth highlighting here?
Yeah, so this is a really fun. I think any prototype that allows you to like make your own videos, it's fun, And so I think the analogy that people might be familiar with is like Sora or something like that. I think from OpenAI, there's a lot of sort of similar technologies that end users might use as tools, but the idea is open source has actually created the technology to put these into your hands, where if you have the hardware to run them, you can run them just at the cost of using the hardware. And so vLLM-Omni is a multimodal inference server that actually runs on top of core vLLM that allows you to do multimodal. So what does multimodal mean? It means that it can support image, video, and audio. So beyond just text that our historical regression models have, autoregression models have been so good at. And it creates a whole, you can create videos, but you can create much more sophisticated images too. You could think of things like X-rays that have already been marked up with, the findings and things like that. And so very excited about it. We're actually looking at vLLM-Omni along with another open source project called ComfyUI. And so the analogy there is typically with, text-based generative AI, you use a chatbot with your hosted large language model. ComfyUI is sort of like the chatbot equivalent, although it's a bit more like an IDE, development environment where you can kind of express the whole workflow that you want to produce the image or the video from.
And you mentioned, video production, video examples might be hardware intensive. One of the goals of VLLM is to support so many different hardware types. And interestingly enough, one of those hardware types is CPUs. So, there's just an absolute explosion of different forms of accelerators. We know most, the GPU, there's some high profile companies building, Google has a TPU, Grok has their own accelerator, Cerebras has an accelerator, and CPUs can even be used in certain cases. So how do you see all of this evolving, and what are some important things to highlight in that space?
Yeah, I think it's a great observation. I think I'm quite excited about this because I think there are still, the bottom rung of that ladder can be a little too high for a lot of folks for generative AI to be able to use those, whether it's great, ChatGPT is a very low bar just to use. But as far as if you're trying to do self-managed, there's a lot of different challenges around that, like being able to get the software, operate the software. But then the second one is having the right hardware or the accessible hardware. And first time I ever try to run a generative model on a CPU, it reminded me, I'm dating myself here, but like back in 1995, watching a web page load over a 14.4K modem in Africa, which was just like the page coming down. It was just excruciating watching those tokens come out. So not all CPUs work great with this, but Red Hat has been working in the x86 ecosystems advisory group, which is great because it's Intel and AMD, which, for those that don't know, like the x86 instruction set architecture is what the modern CPU is based on. And we work in this consortium with this where we help define the roadmap for that instruction set architecture. And recently, they've come out with a whole lot of matrix multiplication operations, which is pervasively used in inference, right? And so the more modern chips have this ability to do inference. It's not the same as the experience, not quite the same that you get with GPUs. They're more capable, but you can. It's not what I experienced when I was trying to do it on an old CPU. It's much more performant, and so it sort of opens up this opportunity that for certain use cases, which I would just broadly describe as like your inter-token latency, the time between when one token arrives and the next one arrives, is about 100 milliseconds or more. If you can deal with that, like CPUs are a good option, and from a Red Hat standpoint, often when we talk to our customers, they're like, hey, these GPUs are scarce, but man, I've got a lot of CPUs. Can I use those? And so now the answer is yes, and so I'm quite excited. This is like we're driving the x86 work into the vLLM-CPU project, so enabling VLM on CPUs. And this will open up VLM to a much broader audience, including, being able to run it on your MacBook and others. But I will say, like, another reason this is interesting is power budgets. So in differing geographies, if you're running self-managed, to be able to do generative inference, you do have to reason about how much power you can deliver per floor tile in your data center. And then you're sort of backing into a system that doesn't exceed that budget, So I think CPUs give you flexibility there. I think another place where you get a lot of flexibility is inference-focused accelerators that, aren't GPUs. So I think here where you see things like Cerebrus or Grok or IBM Spire, right? So GPUs are very powerful accelerators in themselves, but they're not designed ground up for inference, right? They do video games, they do crypto, they do AI. And because of that, they're not tuned to be specifically power efficient for any one of those. And there's a whole class of new accelerators coming that are inference focused and they're power optimized for that. And I think that's going to, between the CPUs and the inference focused accelerators, going to open up a very different story going forward on hardware for us.
Yeah, I think that's important. We've done some of the initial work with disaggregating prefill and decode, in part preparing for heterogeneous infrastructure, and then you can really reduce the cost of the infrastructure required to support the models, change that inter-token latency. So for real-time responses, maybe use some hardware. For non-real-time responses, another hardware. So I think that's really the future will look like a much more heterogeneous space, and we can optimize for power budgets or financial budgets or time budgets.
Absolutely. That's a great example. Like, I think in the LLMD piece that you're describing, some components are CPU bound, some are memory bound, some are IO bound, and being able to get the right tool for the right job, in a architecture, I think is important. And I just would call out, there's an exciting project that we're working on that we actually created. It's led by our PyTorch team in Bengaluru, but it's called OpenReg. And this is in core PyTorch itself, and it's to move the accelerators from in tree, like in the core code base, to out of tree, so that they basically can be developed outside of PyTorch without slowing the development of PyTorch down.
Yeah.
But IBM Spire, which is one of these low-power inference-focused accelerators, is going to be the first embodiment of this. And I'm excited about this more just generally. If I take my red hat off and like talk about this as an open source nerd, like what this allows is, for the first time, we're starting to build touch points into PyTorch for an open ecosystem. So all these little startups that are doing the hard work to come up with new silicon, etc., like their ability to get their innovation into PyTorch, which is the seminal project in both pre-training and inference, just got that much easier, and I think that only makes things better.
Well, we talk a lot about inference, mostly I'll call it real-time inference. There's batch inference, and then there's other batch jobs that look like big training jobs, pre-training or post-training. Slurm comes up a lot in that context. Work that you're doing around Slurm or non-inference focused workloads?
Yeah, you're right. This is kind of interesting. Whether we like it or not, there's aspects of technology which are tribal, and people like to use things that have been working for them for a long time. And Slurm is a very successful, widely deployed cluster orchestrator or scheduler that's very popular in high-performance computing environments, which is also a place where GPUs are widely deployed. And so, whether you're I would just say that if you have a provenance as an HPC environment or HPC cluster, you tend to often start your journey on generative AI around the AI infrastructure with that same infrastructure. And so Slurm is quite popular there. However, it's more of a batch-oriented technology. And so for pre-training, post-training, batch inference, it works quite well. And so, what's interesting where I mentioned sort of it's tribal, is sort of like the Kubernetes world, which is very interactive. It's non-batch, right? And it's sort of designed around and essentially like serving web servers, And so it's kind of interesting technological challenge in open source communities to sort of reconcile the Kubernetes way with the HPC way. And it's going to be interesting to see those two technologies come together. I have a research team that runs the Mass Open Cloud, or is a core constituent within the Mass Open Cloud here in New England, and they build solutions that research IT teams can use. And one of these is they've done a prototype around Slinky, which is an operator to allow you to run Slurm inside Kubernetes to sort of bring those two worlds together. So I think that's one way, but it will be interesting to sort of see the PyTorch Foundation and its projects evolve and the Kubernetes projects evolve, and hopefully they can find a path where they work well together synergistically,
Well, we started off sort of talking about tasks and the relationship between humans and AI, and miraculously we've made it all the way till now without talking about agents.
Yeah.
And so there's a lot with agents. There's the agents themselves, the agent's ability to leverage models, the data associated with agent workflows, the standard operating procedures that are typically stuck in our heads and not easily describable to agents that we're slowly building skills.md files around, or things that we can start bringing agents into the human world. A lot of privacy and security concerns around agents and how they work. Are there areas that you're particularly interested in or paying attention to from the emerging tech world?
Yeah, great question. Well, yes. And so one of the areas we're looking at is the intersection of small language models and agents and reinforcement learning. And so typically, a small language model is a model that's smaller, that's tuned for a specific thing, and an agent is a discrete piece of functionality that leverages a model for a specific thing. So they're sort of like a match made in heaven. And so we've been exploring post-training small language models in a certain way that best supports agent performance. And so this is where we'll be starting to look at reinforcement learning, which is a very popular approach to sort of close that last mile around agent performance, not from a speed standpoint, but like how well does it do the job that you're wanting it to do?
Yeah.
We're looking at a couple of different projects. So, I mentioned earlier, we do a lot of pathfinding for Red Hat. Some of this is, working with our product and engineering teams, and they're like, look, we know reinforcement learning is a need, but there's 8 different ways to do it. Like, can you go figure out which one we think should be the one we focus on? So we're kind of doing this right now. It's interesting. You have SkyRL that comes from UC Berkeley, which is also where vLLM comes from. It's also where Spark comes from, and Mesos, and a lot of other things. They're very prolific in their innovation. And then you've got Monarch that comes from the PyTorch Foundation and Meta. And so we're sort of looking at those, but say like there's a third thing that's quite interesting that we're exploring, which is, if you go and meet with a lot of the different Bay Area startups that are helping people build agents, there's also this technique that they're using where they're building a semantic representation of the data estate of a company, and then using that to rapidly create agents and use reinforcement learning to close that last mile. So right now, I would say we're in the experimentation phase, but we're working in that space to identify like what path we think will be best for our technology stack and our customers. And because essentially kind of the other thing that we do is make technology easy to consume into the platform. And so we spend a lot of time thinking when we think, well, which project do we pick? It's not just like speeds and feeds and like capabilities. It's also which one has the healthiest community, the best governance, so that if we feel like we can bet on it for a while, then our customers can too.
The governance and community experience in an open source community has always been really important to Red Hat. And it's interesting because even that's shifting over time. We have to discuss how we enable agents to submit pull requests or merge requests to projects, and where that's AI slop versus high value contributions, what that looks like. How do you onboard an agent to a project?
Yeah.
A lot of interesting opportunity here.
Yeah, absolutely. And I think, that's a whole separate thread on agents. We actually do have a few teams looking at that, like what is zero trust for agents, at a high level. But I think there's, in your sense, you're also talking about agents as my junior assistants or agents as my team member, and having that autonomy to be able to act on your behalf, and what are the implications around identity. And we have we have projects around Spiffy and Spire that are exploring that intersection. But it does sort of come back to like kind of like one of the original things we're talking about is that, this treadmill, I would just say this treadmill's running so fast that it kind of changes the open source governance game, right? Like, so I have different teams that some are not focused on AI, and their dynamic is different. Their world doesn't change near as fast. AI changes so quickly, and it is tough to build communities when there's a project that's like here today, gone tomorrow. And so that is also sort of part of the challenge, is identifying what to bet on, and will it be around in 6 months if we bet on it now?
Yeah. Well, Steve, it's been awesome to catch up and get a glimpse into the emerging tech world of the Office of the CTO here at Red Hat. Really appreciate your time and insights and sharing with us what you've got brewing in the background.
Sure. Always my pleasure to nerd out with you, Chris.
This has been a fascinating look at this year's AI landscape. It's a reminder that while the tasks of AI change weekly, our purpose, building reliable, open, and sovereign systems, is a constant. The real engineering work is no longer just about a chat interface. It's about the semantic layers and hardware optionality that allow an agent to securely navigate an entire enterprise. We're moving from tools that just answer questions to systems that will be able to integrate context, whether that's a lines of code summary or an X-ray notation, and transform that into specialized action. The secret sauce is no longer just model weights. It's the infrastructure that orchestrates and protects them. Thanks for joining the conversation. I'm Chris Wright, and I'll see you next time on Technically Speaking.